Welcome to FPGA Magic. Today's project is with LED matrix panels. They come in many pixel pitches or sizes. Our macro supports panels with 8:1 and 16:1 multiplexing, or generally 32 by 16 and 64 by 32 panels. Our macro and daughter card are designed around the Hub 75 standard interface, as shown in the picture. The macro supports either one 64 by 32 panel or up to four 32 by 16 panels. The macro is driven through the serial port with Python code. In our example, the macro is shown daisy-chained with a port that drives the three LEDs on the FPGA board. The pinout for the board is shown. If you double-click on the macro, it will bring up the top diagram. The output controller requires 2 lines of memory to be available, or 6 bytes total for both lines. FPGA memory is very precious, so I always try to minimize its use. Since only 3 bytes are required for each line, the unused byte was deleted from the memory. This required a little bit of work, as shown by the complexity of the diagram. Otherwise, just 2 4K memories could have been used. The macro defaults to a 16:1 scan for the 64 by 32 panel. If you want to change it to 8:1, you change the setting to a 1 and remember to leave the quotes in. This is an overview of how panels are driven. Only 2 lines can be lit at any one time. The LEDs are full on, so the hardware has to pulse width modulate the LEDs. The easiest way is to write out all of the least significant bits on the line, wait a little bit, and then continue on to the next bit with double the wait time. There are 3 bits going out for each of the RGB colors. Then as you complete each line, you go on to the next line. There are either going to be 8 or 16 sets of lines. The memory map is shown for a 64 by 32 panel. Note that there are 4 bytes per each pixel, and the data is in Little Indian. Also shown is the memory map for 32 by 16 panels. Note that not all panels need to be present. This is the example Python code to test the output. When the code is run, you will see the following display. Note that I have included a ramp of the red, green, and blue levels so you can see the full 8 bits of intensity is supported. To get the best results when displaying pictures, you need to add gamma compensation to your display images, where a nominal value of 2.2 will provide pretty good results. Thanks for watching.